Hello everyone, I'm Helano, and today I'm going to present the work entitled A Course to Find Corneal Ulcer Segmentation Approach using UNet and DexiNed in Chain. I received a bachelor's degree from the Federal University of Education, Science and Technology of Maranhão in 2018, and I am currently a master's degree candidate in computer science at the Federal University of Piauí. The researchers that developed this work were me, Helano Portela, Rodrigo Veras, Luiz Vogado, and Daniel Leite from the Federal University of Piauí, Teresina, Brazil, and Jefferson, Sousa, and Anselmo Paiva from the Federal University of Maranhão, São Luís, Brazil, and João Manuel Tavares from the University of Porto, Portugal. The agenda that we will be following today begins with the introduction, the objective of the research, the related works, material and methods, the results and discussion, the proposed method, and finally, the conclusion. Many corneal diseases may affect the eye health, such as pterygium, infection, and also corneal ulcers. The corneal ulcer is one of the most frequently appearing of these, and it is defined as an inflammatory or even more severe condition. Here we have some examples of corneal ulcers. In the top row, we have the point-like general type of corneal ulcer. It is represented by micro dots along the corneal tissue, and it represents a very early stage of this condition. In the middle row, we have the point flaky mixed corneal ulcer general type, which represents a mix of the point-like general type and the flaky general type, being the point flaky general type a intermediate level of this condition. And the flake general type is the most advanced stage of this condition. So this study consisted of developing a computational method for corneal ulcer segmentation in ocular staining images. For that, we evaluated and compared different CNN architectures and post-processing techniques found in the state of the art. To do so, we tested the UNet, DexiNed, and LinkNet CNN architectures. We also evaluate pre- and post-processing imaging operations, training the models using only point flaky mixed corneal ulcer images, and validating them using flaky corneal ulcers images. So here we have a summary of the works found in the reviewed literature in terms of the year of publication, the techniques, the number of images, and the application domain. From those, we can highlight the work of Deng et al. From 2018, which used a SVM with superpixels to segment corneal ulcer images with a data set of 150 images, which was also the number of images used in the work of Liu et al. From 2019, also applied to corneal ulcer segmentation. For the material and methods, we have the dataset SUSTEC-CISU with 712 ocular staining images, and from those we used the 358 point flaky corneal ulcer images in order to train the models, and the 91 flaky images in order to test the models. The 263 point-like images don't come with the ground truth from the data set, so it wasn't possible to use it in our experiments. So also we tested post-processing techniques such as auto thresholding, morphological GAC, and morphological operations. For the metrics, we have these metrics, and the most important of them were the average dice coefficient and the true dice coefficient. If the average dice coefficient is calculated using dice coefficient of each image, a sum of all them and divided by the number of images, and the true dice coefficient is based on a score where this score is equals to 1 if the DC value of a such or a specific image is above a threshold, in this case 0.7, otherwise it is equals to 0. So the TDC is the sum of all of the scores from each image divided by the number of images. So the results obtained using combination of DexiNed, LinkNed, and UNet architectures along with the post-processing techniques were these ones. And from those we can highlight the combination using the DexiNed, followed by the morph GAC using the auto value as a parameter, which got 99.0 for the sensibility metric. We also have the combination using the UNet, followed by a binary thresholding operation that had the recall score of 96.40, and the combination using the UNet connected to a also thresholding operation followed by a morphological operations with the best result for the ADC metric. And the combination choosing as the main method for this work was the combination using UNet connected to DexiNed, followed by a morphological GAC, which had a sensibility metric of 99.0 and the best true dice coefficient with 63.7. Here we have a flowchart of the proposed method. First, we submit the raw images along with its user label in order to train the UNet, and we get the UNet output and submit to the DexiNed using a user edge map in order to train the DexiNed architecture. This way we have both trained UNet and trained DexiNed. This way you can submit a raw image to the UNet and we get the UNet output and submit it to the trained DexiNed, and the same way we get the DexiNed output and submit to the morphological GAC operation, and this way we get our final result, which is the segmented image. Here we have an output of each one of the layers of the method. Here we have the raw image, which is submitted to the model, and the UNet output, which is the output of the first layer of the method, the output of the DexiNed, which is the second layer of the method, and the final result, which is provided by the morphological GAC operation. So here we have the ground truth provided by the dataset, which is very similar to the result provided by our method. So here you have the best results. The best result of the samples tested, and the median result from the samples, and the roast result from the experiments. The best result got a 96.91 dice coefficient, and the median result with 75 0.47 for the dice coefficient, while the worst result was 0.0. So comparing our work with the existing works of the state-of-the-art, we find that our work achieved the best result for the sensibility metric compared to the work of Lima et al. And we got a ADC value of 7.70.50 for the ADC metric, while the best result for this metric was the work of Liu et al. It's important to point out that our method used a total of 449 images, while the other works used a dataset smaller than 150 images. So we can conclude that the combination of the UNet output connected to the DexiNed model achieved better overall results when using the DexiNed A prediction output with the morphological GAC with the auto threshold value as a parameter. It is important to point out that we could only use point flaky corneal images with not accurate ground truth to train our model, and however, we achieved very encouraging results. Thus, we think that our model could generalize the training data in order to segment corneal ulcer images. So, if you have any questions about this presentation, feel free to contact me from one of those sources, and thank you.